we are going to start with refraction. Refraction of light we have studied, right, through the surface. Now we are going to discuss about refraction of light through prism, right? So reflection of light, reflection of light through prism, through through prism. Is everything is okay? Okay. So there is a prism. Prism is like this, right? This is a prism, right? This is called P. This is called Q. Oh, it's not required, but anyway, if I wrote, then thank you. Now again, this is the normal of this side. Normal is perpendicular to the refracting surface. So this is the normal of PQ, right? And and it is the normal of PR, right? Now, 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 incident ray comes. Incident ray comes like this. This is the incident ray. Incident ray is coming like this. So this is angle of incidence, right? When light ray glow, this is air we have, and prism is made up of glass. So this is glass. So so when it goes from rarer to denser medium, then it goes towards the normal. So it goes like this, right? This is angle of refraction 1. This is angle of refraction 2. Fine. And when you extend this light, this angle of this incident ray you extend like this, right? Oh my God. This is it is extending like this, and okay. Now it goes, it gets emerged out. So this is emerge out, right? It is emergent ray. This is incident ray, incident ray, right? This is angle of incidence, and this is angle of emergence. This is angle of emergence, and this is emergent ray, emergent ray, right? So what happens when we extend this ray also behind? This is we extended upward, and this is we behind we extend like this, right? So this is known as, this angle is formed, right? This angle is called as angle of deviation. Angle of deviation. Angle of deviation. Right? That we call delta, sigma. Right? This is angle of deviation. Right? And there will be angle of deviation 1. There will be angle of deviation 2. Right? And this will be angle of prism. This is called angle of prism A. It is angle of prism, right? So refraction of light through prism is depending upon the incident ray, angle of prism, material of the prism, and wavelength of the light. Yeah, factors affecting factors affecting factors factors affecting affecting refraction refraction through prism. Oh my god. Oh, this is sure. Oh. So factors affecting refraction of prism is first angle of prism. Angle of prism. Second, angle of incident ray. Incident ray or angle of incidence. Third, third, material of the medium. Material of the material of medium. Right? And fourth is wavelength of light. Wavelength wavelength of light. Right? This is we have. Now these are the factors. Now we go for proving. You know this you have studied. If we talk, if I say this is M, this is N, and this is S, right? Right. So what happens? And this we call say O, right? So we can write in triangle OMP, OMN, right? Exterior angle is equal to sum of opposite interior angles, right? Geometry. So exterior angle is sigma, right? And this is and this is sigma 1 plus sigma 2, right? This is one we have. Now if you take angle of incidence, angle I is equal to angle of refraction 1 plus angle of deviation 1. That is why? Due to vertically opposite. Vertically opposite. Get it? Now similarly angle E. This is angle E. This is angle I. This is angle E. Right? emergent. So angle E is equal to angle of refraction 2 plus angle of deviation 2. Right? They are also equal because vertically opposite. Right? When you add these two, right, then you get angle I plus angle E is equal to R1 plus R2 plus deviation 1 plus deviation 2. Right? This much you understand? Okay, you have written also? Okay, keep writing, keep writing. Diagram is required. This factor affecting you have done. So this I am going to rub. Now done. Okay. So now you know this is normal to this surface. So this angle will be of 90 degree, and this is normal to the surface. So this will be of 90 degree, right? So if I say in in quadrilateral 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 PMSN PMSN, right? Angle PMS plus angle MSN plus angle PNS plus angle MPN MPN is equal to 360 degree, right? So here I already told you that angle PMS, this is of 90 degree, and this angle PNS, it is also of 90 degree, right? And this is angle of prism A, right? So when you add all these MSN, right? So what happens is equal to 360, right? So one, so 90 90 180 or 360 minus 180. So you get angle MSN is equal to sorry uh, plus angle A is equal to 180. So angle MSN is equal to 180 minus angle A, right? This is So it means this angle is of this angle is of 180 minus angle A. 180 minus angle A. Getting? Okay. Now this much you understand. Uh, should I rub this part, some part of this side, because it's very difficult for me to okay. So this is we call, as usual I'm used to of writing, this is angle of deviation, right? So this is angle of deviation. Forget about this. Now in triangle, MSN, MSN by angle sum property of triangle, sum of all interior angles, hello, all interior angles is 180 degree, right? Oh my god, now it's okay. No, no it's not. Okay, wait for a while. आ गया? Anyway, so I told you this is also right. Sum of all interior angle is equal to 180 degree. So we can write angle NMS plus angle MNS plus angle MSN is equal to 180 degree, and angle NMS is angle R1 plus this is angle R2, MNS is angle R2 plus angle MSN is equal to 180 minus angle A, 180 minus angle A is equal to 180 degree. So this 180 and 180 is cancelled out, right? And this A comes on the other side of equal. So it is angle, sorry. So now we have R1 plus angle R2 is equal to angle A. So it means angle of prism is equal to angle of refraction 1 plus angle of refraction 2. So this is we get angle of, right? This is the angle of prism we have, right? Now, should I rub? This much, I'm going to rub this one, right? So what happens? This equation, you know that, right? This equation, you know that. Keep remember that the an angle of deviation. This is I wrote angle of deviation is equal to angle of deviation 1 plus angle of deviation 2. That you have to keep in mind, right? This I told you. So if I write, if I write angle of incidence, angle of incidence plus angle of emergence is equal to angle R1 plus angle R2 plus angle of deviation plus angle of deviation 1 plus angle of deviation 2, right? So this R1 plus R2 is equal to representing A, and this delta 1 plus delta 2 is delta. So we can say that angle of incidence plus angle of emergence is equal to angle of deviation plus angle of prism plus angle of deviation, right? My God, this is, so this is the relation we have. Angle of incidence is equal to angle of emergence. Angle of incidence plus angle of emergence is equal to angle of a prism plus angle of deviation. I hope you understand. So this is we have about prism, right? You have written? Okay. Now we have uh, about angle of this. You have to keep in mind that angle of incidence plus uh, angle of incidence plus angle of emergence is equal to angle of prism plus angle of deviation, right? Right, right. Now, should I rub this? Okay. So now, as I told you, as we know, angle of incidence plus angle of emergence is equal to angle of deviation plus angle of prism, right? But if angle of incidence is equal to angle of emergence, right? In that case, you can write 2 angle I is equal to angle of deviation plus angle of prism. We bring this angle on this side, so we called it angle of minimum deviation. Angle of minimum deviation is equal to 2 angle I minus angle A, right? This is this is known as angle of minimum deviation. Yeah, right. And deviation is which is something different. We will discuss later. But here I told you that deviation is inversely proportional to wavelength. If means if wavelength is more, wavelength is more, deviation is less. Deviation, deviation is less, and and wavelength is less, deviation is more. Fine. I hope you heard that red color is having wavelength 8000, approximately 8000 angstrom. So, so maximum wavelength, maximum wavelength. So minimum deviation, minimum deviation. So minimum deviation, right? Deviation. Travel in a straight line. Travel in a line, right? And therefore used in signals, right? Signals, right? And and violet color, violet color, violet is having a wavelength of 4000 angstrom. Minimum wavelength, minimum minimum wavelength, right? Therefore maximum deviation, maximum deviation, deviation, right? You already read that rainbow, white light is made up of 7 colors, है ना? You read ना? White light, white light, white light has 7 constituent colors, constituent colors, right? That that we call, that what we call, that we call Vibgyor, right? Vibgyor. So this is red, this is orange, this is yellow, green, this is blue, indigo, and lastly we have violet, right? This is what we have. So this much is not required here. This is in this section in your book. This much is written only, right? So now should I rub this? You're writing. Okay, keep writing, man. चाय नहीं है ना, चाय कम हमने पी ली थी। Done? Okay, let me give some water. Huh? Uh-huh. Okay. Ah. Ah. So you have done this much, and I hope you understand, huh? Okay, good, very good. Should I rub this? Yeah. Now, now we are going to discuss one more thing. That is, you know, this is say water, right? This is refracting surface. This is refracting surface. So this is water, right? This is denser medium, right? And this is air. Fine. Now you have a object here. This is we called O. It is object, and perpendicular to object. मतलब perpendicular. This is a normal, right? This is normal, like this, right? This is say O. This is say A, right? When light ray goes like this, right? So there will be a normal again, and which is passing through point of incidence. This is the normal passing through point of incidence. This is incident ray. This is angle of incidence, right? When it goes from denser to rarer medium, it goes away from the normal. It goes away from the normal, right? This is angle of refraction, right? So we can say that light ray, light ray, light ray from denser to rarer medium goes away from normal, away from normal. ठीक है? So this goes away from the normal, and say Adrika is there, right? This is looking. like this, right? So it seems to be coming from here, coming from here, right? It seems to be coming from here. So image is said to be here, right? This total OA is known as, are you there? Hello? So did you understand what I told you? Hello? This is the refracting surface. This is water, denser medium, air. It is rarer medium, right? And there is an object. This is normal, and then there is incident ray. After refraction from denser to rarer medium, it goes away from the normal. So it goes away from the normal. So this is angle of refraction, right? And this is angle of incidence, this is angle of refraction. And when if Adrika is looking from here, so this she will find this line is coming from here. This is image. So this total distance is known as real depth. This is called real depth, right? And this is known as apparent depth. Apparent depth, right? Apparent depth, right? So apparent means seems to be. So if you see these two lines are parallel, OA, if I say this is, you know, this is B, right? This is M. So OA and BM are parallel. So when they are parallel, then this angle will be of incident angle, angle I, right? And this is angle R. So why their angle I is equal to angle R? Because alternate interior angles. Alternate interior angles, right? And here this is angle R and this is angle, this will also angle R. That is, they are corresponding angle. Corresponding angle, right? So if I say refractive index of, since it is coming from water to air, so we will write refractive index of air with reference to medium is equal to sin I upon sin R by Snell's law, by Snell's law, right? And angle I is equal to, sine means this is the angle, this is perpendicular. So AB upon OB, perpendicular upon hypotenuse. This is perpendicular, right? And this is hypotenuse. So AB upon OB, AB upon OB, fine. And sin R, if we talk about sin R, then what happens? Sin R, then this is angle This is perpendicular, this is hypotenuse, right? So it means AB upon BI, right? So we can write here AB upon BI. Fine. So this AB is cancelled out and they will be inversed. So refractive index of medium A with reference to material is equal to BI upon OB, right? Now, now suppose, suppose distance, distance between AB is very small. So can be neglected, neglected, right? So in that case, this OB will coincide with OA, right? OB on OB will coincide. OB is equal to OA is equal to real depth. Getting? And similarly, this this BI is equal to AI, right? So this BI is equal to AI is equal to apparent depth, apparent depth, right? So when you put these values in in this, so you get refractive index of air with reference to material is equal to AI upon OA, right? It means it means apparent depth, apparent depth upon real depth, right? And hello. So now by law of reversibility, by law of reversibility, reversibility, right? Refractive index of medium A with reference to material into refractive index of medium with reference to air is equal to 1, right? So refractive index of medium with reference to air is equal to 1 upon refractive index of air with reference to medium, and that is equal to A upon I, A upon AI upon OA. So 1 upon AI upon OA, When it get inversed, so it becomes OA upon AI. Right? I hope you understand this. So this is we have refractive index of medium with reference to air is equal to OA is real depth. OA is real depth. Right? This is OA is real depth and AI is apparent depth. Here it is written. So this is we have. Right? Should I rub this? What it is? I'm writing. I'm just rubbing this. This thing is not required very much. Right. This is not required. So at last we can say refractive index of medium with reference to air is equal to OA upon AI is equal to real depth real depth upon apparent depth apparent depth, right? And this apparent depth, this apparent depth is equal to real depth upon refractive index of. So we can say that apparent depth apparent depth is equal to real depth upon refractive index of medium with reference to air. Getting up to here you have written. Keep cutting. So you have done. Hmm. Okay. So just I'll take just few minutes, seconds more. Should I rub this? Okay. So I told you, yeah, you know that shift is what? Shift is equal to real depth, real depth minus apparent depth. apparent depth. Did you understand the meaning of this, what I wrote? I hope you understand. Yeah, this is the surface, right? I told you this is the object, right? This is the object O, right? And light rays are going like this, right? This is the normal, right? This is, and it gets deviated, so it goes on this side. This is angle of incidence, this is angle of refraction, and it seems to be coming from here. This is I, this is object, this is I, right? So this is real depth, real depth, right? This is apparent depth, apparent depth, and difference between these two, real depth, real depth minus apparent depth. Apparent depth is equal to what? That, because that I wrote shift. Hai, recalled it? So this is, we have what? Where is shift? This is the shift from here to here. This is called shift. I hope you understand. Okay. Yeah. So now real depth, and what is apparent depth? Apparent depth is real depth upon refractive index of medium with reference to air, right? So finally we get shift is equal to real depth bracket 1 minus 1 upon refractive index of medium with reference to air. I hope you understand this much. You understand na this much? So is it visible also? Okay then.